So 17, you got 4 for your final answer in part B and 6 for part A. 19, you got 5 in A and 7 meters in B. And then in 21, we got 332.965 billion. 23 for part A, you got 2 miles. Part B, 2 pi r delta r. Delta r is the same as dr. So if you had dr, that is also fine. And then part C, you had to put that into a word justification. So again, the area found corresponds to the area of the circle, and the given equation corresponds to the population density. So together, they equal population. So again, I know the back of the book has your answers, so maybe you already checked through a lot of these. I try to show you a little bit more work. Remember that if you have decimals, it's a calculator question. So 25 would have been a calculator question. Okay. And then we jump to 27. So again, as you're working through these problems, we're noticing that different techniques are all sort of coming back. Hopefully 27 you could kind of recognize and see that that was your summation type formula. 31 was false. Displacement is the integration of the velocity because it is positive. And then 32 is true because velocity is positive. The integral of the velocity is equal to the integral of the absolute value, which represents the total distance traveled. 33 was C because 12.12 times 50 times 6 is 3,600. 34 is D. $35 is B. And 36 was A. Anything you want to see from 7.1, anything you need to see a little bit more in depth? Questions, comments, concerns? I think 7.1 was probably the easiest of all the homework assignments because it's sort of the connection between like chapter 6 and chapter 7. Then we moved on to 7.2. So 7-2 was areas in the plane. We talked about the area between the curves. So we talked about if you had two curves, you did top minus bottom. We also looked at right minus left. So we talked about integrating from left to right and right to left. I did not number some of my work. That was not very smart of me. Okay, so again, these were your odds. You did 1 to 19. So let's put up just the answers to the back. I didn't number when I did my work. It was not very smart. I know that's one towards the end. Let's see if I have my work number. There we go. So again, my numbers aren't going to perfectly match yours because I adjusted your assignments just because we're a little bit further. We took it a little slower this year, so I made some adjustments. So number 1 was pi halves. Jumping over to number 5, you had 128 over 15. So skipping 7. Number 9, you had 5, 6. 13, you got 16. So we can check. I have 13, 15, 17, and 19 down there. I'll zoom in on 17 so we can talk about it. And then 19. 19's a pretty classic one because in 19 they give you the A to the A and the B to the B's, and you have this question in which it's all generalized. And essentially when it's in general, you get an answer that's in general, and that tends to throw us off because we like our answers to be numerical. So 19 is one of those questions that is in terms of another variable, which can totally throw us off. Okay, questions at all on the 7-2 homework? So again, I can walk through any of these from beginning to end. Okay. There's an actual charger on the wall too if you need to seal it. Do you need to borrow one to go?
No. Does it light up?
It's on the side, it's right.
Okay. I'm just gonna leave it.
You're okay. No problem. Okay, and then if there's no questions on that 7-2, we'll jump over to, oh look, there's 3 and 7 for you, and 11. So like I said, I had broken this homework up at one point into different days to match the Y's and the X's. So 3, 7, 11, these ones are in terms of dy. So in 3, you got 1/12. In 7, you had to use your calculator because the intersection of those two curves wasn't a value that you could just get easily. So in 7, you would have used your graphing calculator. I put sine x into y1, 1 minus x squared into y2. Use the intersection key to find what I call like the x1 and x2 intersection points. And then you just do math and go to the integration. Now yours is a little different. Back in the day when you had the older calculators, it actually looked like this. Now you can actually do your integral. You would do the lower to the upper, and then your y2, which is your right, and your y1, which was your left. And you should have gotten 1.6702. Similarly to number 11, find those 2 points of intersection, and then it's right minus left. Okay, and then we jump to section 4.3, 4373 on page 406. And we did 1 through 10. So here's number 1. Number 2. Okay, number 3. Is everybody okay with number 2? Questions, comments, concerns? Remember, I will answer, talk about, walk through anything. Here's 3 and 4. So I honestly think this section is probably the hardest section because it's such a difficult concept to visualize sometimes. You can like see in 5, like I tried to draw that. But again, my 3-dimensional drawing skills are not wonderful. So in number 5, you had to find your like width or your W across and then use that to find the area. So area of a square is that 4 times your length, and then if it's a circle, it's 4 pi r squared. So in this case, you have to square that r value, and then that's how you have your 2, and your square root goes away. Then we get all of that from the previous part in 1b up above. So again, you're taking into account area of a square is side squared, area of a circle is 4 pi, or area of a circle is pi r squared. So all of that's coming into play as you work through these problems. So most of the problems are going to be squares, circles, and triangles. So if my cross section is perpendicular to x, like this one, and you're doing your square, then you do your dx, factor out your 4, and integrate, and you get 16/3. Okay, so then again, like I said, kind of adjusted. So here's 9. I might have to give you 6, 7, 8, and 10. So for 9, you had your trig function sort of coming back into play. Again, our cross section is perpendicular to the y's, therefore we had to do a cross section with respect to dy. Okay. There's 7, 8, and 10. So a lot of times when you see trig, we're thinking calculator questions just because oftentimes trig intersections are going to be decimals or square roots, which ultimately lead to decimal solutions. So any questions on 7.3? Do you want to maybe look at one of the trig functions? So like, especially a trig possibly with respect to the dy's. I feel like it's been a while since we really talked about trig, and I feel like trig in general is usually one of our areas of concern. Did everybody do okay with like the number 9 that was on the last page? Do you want to walk through number 9? Yes, walk through number 9. Yeah, like I figured that's kind of one of those ones you would maybe want to see worked through a little bit more in detail. So let's sort of just walk through number 9. From top to bottom. Okay, so number 9 on page 407. The original problem says to you, the y-axis is our axis of rotation. So it says find the volume of the solid generated by revolving the shaded region about the y-axis. You are given x equals tan pi fourths y. So you're automatically even given your equation as an x equals. So right away, when I see that I'm given my equation as an x equals, I know that I'm integrating or looking at this with respect to the perpendicular x. So we are given even a little bit of a graphic design. So what that does is that tells me that these are my r's or my s's, whatever variable you like to say. The reason I'm picking r is because if you think about rotating this around that axis, that's going to create a cone type shape. So if you start to rotate that, which is really what we're doing when we're finding volume of a cross section, you're rotating that function around that. Well, this top area here is going to form a circle. So in number 9, when you start rotating that, you're getting a circle. So the area of a circle is pi r squared. The radius of the circle would be the distance from the y-axis to my equation, which is what was given to me. So my area is pi, my r is tan pi fourths y squared. So to find volume, volume is the integral of area, so we're going to pull out the pi, and then we're integrating from the bottom of where that function is to this top max height, which they gave you as 1. So they told you the highest y value was 1 in that diagram. So we're going to be integrating from 0 to 1 of tan pi fourths y squared. So my value or my constant of integration is dy. And then at this point, we're just finding our antiderivative. So the antiderivative of tan squared is kind of like a u sub in a way. Or the alternative is to break it down. So like tangent is really sine over cosine. So you could think of this as like a u substitution with sine over cosine. You can give a lot of different options. Anybody get to this point that tried to do it any of those ways, or is this where we got stuck? Is anybody able to get to this? No? Okay, so some got to this, some couldn't get to this. If you had this on your paper or your quiz, like, would you know what to do at that point? Like, or what would you do if you were given this? Would you change it into sine and cosine? You what? Well, tan squared is not the same as secant squared. I'd probably change it to sines and cosines. And even if you didn't want to distribute your square, so like let's say, because a lot of times we don't, you kept it even like that, then you could say, okay, my u is cosine pi force y. The derivative of cosine is negative sine times pi fourths dy. And then kind of play our distributed game, get that out. To be honest, again, trig functions are typically going to be calculator questions. So you'd have like your 1 over u squared, taking out your negative, taking out your pi fourths. When you move that, you end up canceling your pi fourths with your pi, because you're going to multiply by your reciprocal. So that's going to give you a 4 out in front. And it would be negative. And then you'd end up with your antiderivative of u to the negative 2. So you'd end up with 1 over u to the negative 1, which would also be negative. And then that would cancel with your 4. So you'd have 4, 1 over u from 1 to 0. Which ends up giving you a 4 minus cosine of 0. Oh, I don't know, you guys can't see me. Sorry. So again, cosine of pi fourths would give you root 2 over 2, and then it's flipped. Etc., etc. Cosine of 0. That's so weird. I don't know what happened to mine. Okay. It's the board being the board. Okay? Let's go to the packet. I did try to send a message out to the teams on that packet. So the packet kind of had some issues where we had questions that involved that washer method that I referenced the other day. So I kind of altered the directions for the one problem because back in the day, for 7-3, we had to do washer method. This year they eliminated washer method off of the AP exam. I'll probably be back next year on a normal school year, but it was eliminated this year. So number 1, your multiple choice answer was C, and I just kind of said why it can't be any of the other answers. And number 2, 3, 4, and 5, although your 4 was cut off, we had to use L'Hopital's. And the reason you could use L'Hopital's was you either got 0 over 0 or infinity over infinity the first time you plugged it in. Once you get 0 over 0 or infinity over infinity, then you can take L'Hopital's. and you can take your derivative of the top, derivative of the bottom, and get a final answer. So when you take the derivatives, you take them separate, and then you get a final answer. So it's derivative of the top over derivative of the bottom equals that value. You don't cross simplify from top to bottom until you get a final number. Sure. Okay, and then 6. I'll get there, number 3. At this point, I need to connect the iPad. I said yes. I'm not going to skip it. Just doing it at the end. I said yes, I'll go through it. I just was checking through the rest of the packet. Okay, so we're going through 3, and then here's your 6. You obviously didn't have, forget which one got cut off for you. Maybe 8 in print. So play 6 and 7 again. That's just your final answers in your setup. So if you miss them, you can kind of go through, look at what you accomplished, see maybe what you missed. Probably looking at 8 saying, well, I'm happy you can cut off. And then 9 you could do exactly as is. Now 10 I ended up, actually that changed. Yeah, 10 was one of the ones I think I changed because you ended up with the washer method. So that's the old 10, and then we did 10 with area between 2 curves instead. So I have its work, don't look at that 10. And then 11, 12, and 13 were calculator questions. So here are your calculator answers and work. There's 13 and 14. And we're going to talk through 15 and 16 and kind of grade them more AP style. So let's go back before we go through the AP ones, and let's talk about number 3. And let's talk about number 9 and 10, since those are the ones that I altered the work a little bit for. All right, so number 3, oops, give me 1 second. I gotta get it off my screen share. So for this one, what's happening is we have a L'Hopital's. So the first time you plug it in, you have your infinity, and then you have sine of pi over infinity. And we're like, okay, so this gives infinity times 0, which is what we consider to be one of those special cases. And we know that we can kind of rewrite that so that we end up with a fraction. So what we have to do is, in order to use L'Hopital's, we have to create a way to create a fraction within our function. So we want to be able to rewrite this so we have like an f of x and a g of x. So when I get one like this, I typically tend to move the x so that it goes down to my denominator as like my g of x function. So what I would do is I would rearrange this so that I would say the limit as x approaches infinity of sine pi over x is the same as 1 over x. So now that gives me 0 and 1 over infinity. So 1 over something really, 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 really big is also 0. So you get 0 over 0. So then you can say by L'Hopital's, and then you take the limit and the derivatives of the tops and bottoms. So it's kind of like the limit as x approaches infinity, limit as x approaches infinity, and then you take your derivative. So the derivative of sine of pi over x, well, derivative of sine is cosine times the derivative of the inside. So the derivative of pi x to the negative 1. So again, think about, and even down here, the derivative of 1 over x, that's like x to the negative 1. So what's your rule for derivatives? This is where I think everybody starts to get confused, right? So the rule for integration is to add 1 and divide by your new one. Well, the rule for derivatives is to bring that power down in front and subtract 1. So the derivative of that becomes negative 1 x to the negative 2. And then if you throw a pi in there, it's just negative 1 pi x to the negative 2. So that's going to come out in front. So you have negative pi over x squared. And then down here you have negative 1 over x squared. And then now, once you take your derivatives of each, now you can simplify, because the rules for limits say you can take those constants and you can bring them out in front. So like your negative over negative is going to become a positive. And then your 1 over x squared and your 1 over x squared can cancel. And you get the limit as x approaches infinity of pi cosine pi x over 1. And then we just get pi. And then the cosine of pi over infinity, well again, small over big is 0. So you get the cosine of 0. So cosine of 0 is 1. And we get pi. Okay, so then again, like I said, 10, I started to look at it and I realized that in there you were going to end up with that washer method. So this year we don't have to do that washer method, because what would happen is as you rotate this, you'd have a long radius and then a short radius, and you have to do the long minus the short to subtract away. So like if you found the volume of the outside, then you have to subtract away the volume of the middle, and that's what that washer method is. And they're just not assessing you on that. So then I changed it and I said, hey guys, don't do volume, do area, which you're very capable of doing the area. And again, you could have done the area with X's or Y's. So what I did in 10 is actually show you that you get the same area integrating with respect or integrating with respect to X or Y. So you could have changed your equations to be Y's. You could have left them as X's. Honestly, it doesn't affect your answer either way. You would get 32/3. And then just looking at 9, so what 9 did is change the axis that you revolved it around. So in a lot of our problems, like in the last one I just looked at with you, a lot of times your revolution is with respect to the y-axis or with respect to the x-axis. Well, they can change the line that you revolve it around. So this one's revolved around the line x equals 4. So it doesn't change a lot. It just changes the way you look at your radius. So the radius is still the distance from this line. But now instead of the outermost radius being here, my outermost radius is down here. So what you do is you just change the idea that it's going to be 4 minus that radius. So the equation is y equals 1/2 x. Since we're revolving around the line x equals 4, that makes it perpendicular to the y-axis. So it means we want to integrate with respect to dy. So it's kind of like you have the line y equals 4 going all the way out here, and then you're subtracting away the length in here. So you're starting over here and subtracting away. So again, you're going to have circles when you make this a revolution. So pi r squared, your radius would be 4 minus 2 pi, or 2y. Pi gets factored out, and we would square that. And honestly, when I got to this point, I'd probably even take out a 4. And then you just plug in your 2's. So 4 times 2 is 8. Here, 2 and 2 become 2. 2 squared is 4. 4 times 2, once again, is 8. So those cancel. And then you get 8 thirds. So 4 times 8 is 32 pi thirds. Okay. So 15 is a free response question. So what I want to do is walk through 15 and 16 with you and kind of give you an opportunity to grade and score yourself. So in 15A, the correct answer was no. The amount of water was not increasing at t equals 15 because W of 15 minus R of 15 was negative 121.09. So you got 1 point for an answer with a reason. So if you had yes, you couldn't earn a point at all. If you had no, that kind of got you halfway there, but then you had to tell me why it was no. And the reason why is because it's negative, and if the value of that is negative, then it's decreasing. Because again, W and R are rates, therefore they're like the first derivative. So if your first derivative is negative, then your original is decreasing. Part B was worth 3 points. I think Part B is very validly easy for you to earn those 3 points. You got a point for having the correct intervals of integration and showing W of t minus R of t. Now again, this is a calculator question because of the craziness of the problem. So you did not have to write out the W and R functions. You literally just have to put W of t minus R of t, and you have to have the dt. No dt, no point. Then you got this answer, but it asked for the nearest whole number. So your second point, so your first 2 points came from this line here. Your final point came from this line here, rounding to the correct whole number. And then letter C. Letter C is your EVT. That's your candidates test. Beginning, end, values to make sure they are not absolutes. So anytime you see the word absolute, you are thinking EVT. I see absolute, I think EVT. EVT means candidates test, which means beginning and end, as well as any zeros I get. So these are my CPs. This is my EP for endpoint. So anytime you're looking for an absolute, you got to check the EPs and the CPs. So you got 1 point for finding these 2 critical points. So again, if you're trying to score yourself and see how many points you got out of 9, we're going through that as if it was worth 9 points. You got 1 point for telling me that the amount of water is at a min at 6.494. So the values at the endpoints and the critical points of the absolute min occurs at 6.494. That sentence got you a point. So you got a point for the table, a point for the initials, and a point for the sentence. Part D's down here. Is yours typed a little different? It might be. Oh, your C and D's are flip-flopped. Sorry. Doesn't matter. Just draw an arrow between the two. I don't know how I flip-flopped them. Part D was simply being able to give that limit in the equation. So again, they might have made changes. This was from 2005, which is like 15, 16 years old. The concepts obviously don't change in mathematics, but sometimes they change their wording. Sometimes they would have maybe added a derivative instead of now being all integrals. They've adjusted that aspect. Or A, B and C might be together. But the ideas, the concepts are similar. So again, your goal is to be getting 6 points. If you earned 6 points on this, then you should feel very good. Goal on an FRQ is to get 6 points. 6 points on average for each FRQ gets you where you want to be. Okay, so let's talk through 16. 16 says, let R be the region bounded by the graphs of f of x equals sine x and g of x equals x cubed minus 4x, as shown in the figure to the right. Find the area of R. So area is top minus bottom. So again, in order to figure this out, you would use your graphing calculator. You needed to find where these graphs intersect. Obviously, they start their intersection at 0, 0. But I needed to know this point of intersection right here. So that's 2.100. And then our y value, I didn't write it down. So the reason I need to know where they intersect is to be able to do my top minus bottom, because that's my integral. So I'm finding the area of the curve from 0 to 2.100. And then the top curve is that sine. And the bottom curve is the g of x. So to find the area, it's 0 to 2.100 sine x minus x cubed minus 4x. And if you did this by hand, don't forget that that negative is going to distribute into both of those. So that's kind of a common error when we do this by hand. We put the negative on the x cubed, but not on the 4x. But being that this would be a calculator question, finding that point of intersection, etc., all you'd have to do is write that down, then give me the little approximation, and I'm looking for 5.4628, 5.462, or 5.463. You could have had any of those, because you could have just truncated, or you could have rounded. So any of those 3 decimals would get you your points. Part B, find the volume of the solid generated when it is revolved around the horizontal line. Y equals 2. So again, if you're revolving it around a horizontal line, then that's perpendicular to x's. So our volume is going to be pi r squared to my point of intersection. The only difference with revolving it around a horizontal line is it shifts that graph 2 units up. So if you revolve it around the x-axis, then you don't have to worry about that horizontal shift. If you revolve it around y equals 2, then that 2 just gets incorporated in. So it would be 2 minus and now this time, if you think about your graph, that 2's up here. So which one's the furthest away? G of x. And which one's the closest? F of x. So it'd be the 2, you go out to your G of x, and then also subtract away your F of x. And again, it's all done on your calculator. And then in part C, what is the greatest vertical distance? So think about vertical distance. That's up and down. What is the greatest vertical distance between F and G? So what are you trying to find? You're trying to find a max. Trying to find a max distance. So if we called h of x top minus bottom, if you're trying to find the max length between them, I want to know, okay, when is my derivative? Zero. I don't know, when is my derivative 0? And that occurs, and again, you could use a graphing calculator because this is a calculator question. So if you think about max profit or max length, that occurs when the top and the bottom are going to be equal on their derivatives, or when the derivative is equal to 0. So therefore, that's at 1.2052. So what is the greatest? It says what is the greatest vertical distance? Well, the greatest vertical distance would be h of 1.2052, which is 4.004. So the answer isn't just the 1.2052. It's that value plugged in, and that would be the greatest vertical distance because it is the absolute max of h of x. Okay, and then number 4, or letter D rather, the region R models the surface of a pond. So now we're talking about the pond being a surface. At all points R at a distance x from the y-axis, find the depth of the water. So we're trying to find depth. So depth is kind of that rectangular region, or the area integrated. So it says find the volume of water in the pond. So we know volume is the integral of area. So if we're talking about depth, we're kind of talking about a three-dimensional. So here's the surface of the pond. Now we're going down into that. So it's kind of going down. So I'm thinking volume equals length times width times height. So I'm thinking that we want our volume to be a length times width times height, which means we're going to integrate the area of length times width. So we just said that the width is h of x, because that's the length across at any given point. And now the length down is given by 3 minus x. So 3 minus x is your depth, and your length across is sine x minus x cubed plus 4x. Okay? So go ahead and integrate that from that 0 to 0.2100 on your calculator, and you should get 10.285. Okay, so on Friday, did you guys pick up that other packet that had the volumes of cross sections homework? We worked through a couple of those multiple choice questions. We worked through question 1 on that front page. We worked through 4 and 5. Do you want to do another volume of cross section like question number 2 in that packet? Do you want to look at area between two curves? Do you want to look at the chapter review in our textbook and do a bunch of different problems so you have to decipher what type it is? So again, at this point we've gone through all of the different reviews. Your test tomorrow is primarily on 7.1 to 7.3. Because that is the concepts we have not assessed on. It will be our last chapter test of the year. I mean, I have more volume of cross-section AP questions. I can give you textbook questions. What type of review at this point would be? Where area do you feel least confident in? At this point, I'm looking for feedback from you. And I could tell you just like generalized summaries on what to do.
Knowing exactly what to do from the word problems. It's not too much the math of it, it's knowing what to do.
Okay. So, let's see. Okay, I have some good ones for that. This is kind of just like a generalized summary. Again, this is NIMSY. So, but sometimes I know it helps to read, see, and reiterate. So for area between two curves, the biggest suggestion I can make is to sketch the region and then determine if you're doing dx or dy. And then if it's dx, then remember it is going to be right minus left, and it's the y equation from the right to the y equation to the left. And then if you're dy slicing, it's top minus bottom, which is x on top to x on bottom. I don't like how they mix up the slicing that way. So volumes of cross sections and volumes of solids of revolution, they're a little different. So again, the cross section is what we were looking at in terms of the circle, square, triangle. Like that's where they tell you the exact shape. And then you pick the area equation to plug in. And then volumes of solid of revolution. That's where you kind of have to do your outside radius minus your inside radius. Or if they determine that they're going to revolve it around a different surface. So if they don't tell you what type of shape, it's automatically a circle. It's pi r squared, where that outer radius is the horizontal or vertical line you're revolving it around. So in like the last case, it was that y equals 2. Sometimes it's the x equals 4, etc. So let's look at, you said it's just determining what to do.
Figure out how to set it up, just setting it up.
Gotcha. So again, if I gave you, what is the volume of a solid formed by revolving the portion of f of x equals negative 1/2 x squared minus 3x in quadrant 1. So go ahead, take out a piece of notebook paper. There's graph paper over on my windowsill if you want graph paper, and sketch the shape involved in this particular shape. Let me freeze that so you can take a minute to sketch it. Okay, thank you. So then the question that we ask or propose is, what shape would the cross section look like? So like if you sketched this out now, sorry, I hit wrong button. Once you sketch that, what do you think the shape of that bottom curve made? So as you sketch that and you look at it, what shape is that going to make on bottom? So you're stuck in quadrant 1. We know it goes through 0, 0. You just kind of plotted in or graphed a couple of those points. It's definitely a quadratic. It's a quadratic open down. So again, if you can't see it, it's a quadratic open down. It's kind of narrowed and compressed. And then your other points, you could take out an x here. That left you with x minus 3. So that told me that you had a root at 0 and a root at positive 3. Which tells me that my max is at 3/2. And again, you should have been able to see that even with this idea here. So even if you don't find the exact point, there's your curve. If I asked you to find the volume of this, revolving it around this x-axis, what shape is that going to make? What shapes are these? Yeah, they're semicircles, right? These are, and if you revolve it, it's going to make a full circle. So my shape is a circle. So my volume the volume of a what's the area of a semicircle? Okay, 1/2 pi r squared. And then if you want to talk about the volume revolving it around this, you just get rid of the 1/2. So if you're finding the cross section versus finding the volume, that's the difference. So the cross section versus your volume. So let's do it first with a cross section. So that's going to give me, we're going to take out our negative. I don't want that negative in there. So I'm going to bring out my negative 1/2. I'm going to bring out the pi for pi r squared. And then again, because it's a semicircle, I'm going to also bring out the 1/2 for that. It's going from 0 to 3, and my radius is going to be obviously the curve. So a negative 1/2 and a 1/2 became a 1/4. And then that's why my curve doesn't have a squared. However, when you take out that 1/2, it's part of the equation. So it also is going to get squared even though I factored it out. So a lot of times you'll see me write it in and then take it out. You can take it out at the very beginning, but you have to remember that when you take it out, it's part of that radius, so it is also squared. So a 1/4 times a 1/2 is an 1/8. And actually, I'm just going to integrate here. So you would have to FOIL that to integrate this. So if you like to rewrite it FOILed, you can. So actually, that's going to change. Going to put my 9 on there. So if I do it in reverse, 9x cubed over 3, and then you get minus 6x to the 4th over 4, plus x to the 5th over 5, from 2 to 0. So 2 cubed is 8. 8 times 3. 24. 6 and 4 can reduce to 3 halves. So 2 to the 4th is 16. 16 divided by 2 is 8. 8 times 3 is 24. Oh, how nice, they cancel. And 2 to the 5th is 32. So you get 32 fifths. 32 divided by 8 is 4. Yes, thank you. So grateful for erasable pen. Well, 3 cubed is 27. 27 times 3 is 81. 3 to the 4th is 81. 81 times 3. Oh, 81 times 3 divided by 2. So 8 times 3 is 243 divided by 2. And then 3 to the 5th is 243. Divided by 5. Now, here's the thing. AP says you can stop here on a non-calculator question. AP says you can stop here on a non-calculator question. So tomorrow, you can stop here on a non-calculator question. You can stop once you plug in your limits. You can stop once you plug in your limits. When can you stop? When you plug in your limits. Because this is considered a numerical answer. I have some handouts with some extra practice problems with answer keys already done. So what I'll do is send you some pictures. And if you want extra practice tonight, I have practice for 7-2 and 7-3. Again, there will be some 7-1 on your exam tomorrow. I have practice for 7-2 and 7-3.